for other results, I'll just write the results. You can similarly prove those using series expansion. The third important result is limit x approaches 0, sine inverse x by x is 1. Fourth is limit x approaches 0, tan inverse x by x is again 1. Okay. Fifth important result is limit 0, it's what? You just put 0, you will get 1. The sixth important result is just a modification of the first result, degree by x. Here x is in degrees. Now to find this, what we need to do is we need to first convert into radians. X degrees you can convert into radians as x into pi by 180 radians. Now this becomes of the form, let's say this is y, this is again y, this becomes sine y by y, where y approaches 0. So this is again equal to 1 into pi by 180. So the answer is 1, pi by 180. Okay. So let me ask you one question. What is sine x minus a by x minus a as limit x approaches a? You see, when I put x approaching a, this becomes of the form sine h by h, where h approaches 0. Let's put x as a plus h, then this becomes, this is sine here, so becomes sine h by h. So this again takes the form of sine h by h, where h is approaching 0. So this is equal to 1. So this was some of the important properties, or you can say results, we should remember. Now let's take questions on solving trigonometric limits. Okay, so now let's move on to some questions on trigonometric limits. Let's say I give you this question. In all the questions on trigonometric limits, we'll either use L'Hospital's rule or we'll be using the basic results we had derived. Okay, so this is the question I have been given. If I put x equals to 0, this comes out to be in the form of 0 by 0. So since it's in the form of 0 by 0, I can either use L'Hospital's rule. If I use L'Hospital's rule, I'll have to differentiate this until this form is removed, or instead of using L'Hospital's rule, I can use the results also. Let's say I want to use the results. So 1 minus cos of x, I can write it as 2 sine square x by 2, because we know that 1 minus cos 2x is 2 sine square x. Using this trigonometric identity, I can write 1 minus cos x as 2 sine square x by 2. And this one I can write it as x square. So limit x approaches 0. Now this one I can write it as sine x by 2 by x by 2, sorry, by x whole square, and this is like this, right? What I'll do is I'll just divide by 2 whole square, and this, so I'll write 4 here. Now this x by 2, let me take it as y. So I get, if x by 2 I take it as y, if x approaches 0, y also approaches 0, right? So I'll get this as limit y approaches 0, 2 by 4 sine y by y whole square. And I know that this result is a standard result, sine y by y, if y approaches 0, limit becomes 1. So the answer is half, only 2 by 4. So this is how we solve questions on trigonometric limits. Now let's take another question. Let's say I have asked you to evaluate this limit. Okay, So first let's see what form this limit is of. E to the power x is infinity when x approaches infinity, and this is sine 0, so infinity into 0 form. If I bring down this e to the power x to the denominator like this, okay, then this becomes of the form 0 by 0. Now again, I can use L'Hospital's rule, but it's better I use the standard results. To use the standard results, I know that this is of form sine 0, so here I also have to have the same term like this, so I'll multiply by d here and divide by d here, so it becomes sine y by y, where y is equal to d by e to the power x. Now as x approaches infinity, y approaches 0, and this d comes to the numerator. There is 0. So this limit I know is 1, and so the answer is d. So what manipulation I made is, whatever term was here, I tried to get the same term here, so that I get something of the form of sine y by y, where y approaches 0. The standard trick we'll be following while solving questions on trigonometric limits. Now let's solve one question that had been asked in IIT JEE 2001. This question is also on evaluating trigonometric limits. The question is, evaluate the limit x approaches 0, sine of pi cos square x by x square. So this is the question. This question was asked in IIT JEE 2001. Okay. First of all, you see what form it's taking. If I put x0, this is 1, sine pi is 0, so it's 0 by 0 form. Okay. So I can always use L'Hospital's rule, but again I'll be using the standard results because that becomes very simple. This cos square x, I can write it as 1 minus sine square x, right? Okay. So now sine pi minus pi sine square x. So something like sine pi minus theta is what? It's sine theta. So I'll get sine of pi sine square x by x square. Now, as I said, this term is approaching 0. I should have a similar term here, so that this ratio becomes 1 as x approaches 0. So what I'll do is, I'll multiply by pi sine square x, because this term is here. So here also I need to multiply the numerator with pi sine square x, right? Now you see that as limit x approaches 0, this is 0, so this is 0. So it's sine 0 by 0 form, or sine h by h form. So this quantity is 1. Similarly, this quantity is also 1. So I get 1 into pi into 1. So the answer is pi. This is the answer. Okay. Okay. So we solved good number of questions on trigonometric limits. Now let's move on to the next section, that is logarithmic limits. Okay. For logarithmic limits, you should remember this expansion first of all, that log 1 plus x is this to the base e is x minus x square by 2 plus x cube by 3 to infinity. Now the x lies between minus 1 to 1. Okay. Now this is a very standard result for logarithmic limits, that is log zero. This limits evaluates to 1. You can prove this, just put, instead of log 1 plus x, just put this expansion If I put this expansion and take x common, I'll get 1 minus x by 2 plus x square by 3 till infinite terms and divide by x. I can cancel this 2, and if I now put x equals to 0, it evaluates to 1, as you can see from here. So this is the standard result we'll be following. There's nothing much in this. Let's move on to the questions on logarithmic limits now.